Hello, Keith Rucker here at VintageMachinery.org. Guys, today got a new little project that I'm helping out a viewer friend here. He has sent me part of a governor off of a, a Rumley steam engine. So this is a steam traction engine, I believe. He said it's 97 years old, and this is the governor. On the side is a gear that drives the governor, and unfortunately, it has decided to disassemble itself. It is in pieces. And we're needing to make a new gear for this. So he's basically just took the whole thing out, whole assembly out, sent it to me, make sure I could get the shaft to fit just right. And yeah, first thing I got to do is get this old gear off of here so that we can come up with a game plan. So I think that the game plan is going to be that we're going to actually, I'm not going to try to repair this. I mean, I could probably braze it back together and it would probably be fine, but a better solution is just make a new gear. And I think that's going to be the best thing that we can do here. So probably pull it off. I'll get some measurements on it. I'll model it up in CAD and design a pattern for it in CAD. I will get that pattern 3D printed. We'll send it over to Clark Easterling at Windy Hill Foundry, let him cast a blank, and then once I get the blank, we'll bring it back into the shop and I will machine it and cut the gear teeth in it. That's my game plan. So let's get in here and see if we can get this gear off of here to start with, because that's going to be step one, and then we'll go from there. So this is the governor assembly, and again, here's the gear that we got, and again, you can see the pieces that it's in. Looks like it probably went together, something like that. Don't know which side is in or out. Doesn't really matter. We'll get that figured out here in a little bit. So that's the back side of the governor. It's just got some little flywheel weights on this. Basically, as this thing is spinning, this will spin out, and then it keeps the engine running at a constant speed. So when you put a load on it, the engine slows down, the fly balls fly out a little bit or go back in a little bit, and that lets more steam in so that it keeps it running at a constant RPM. I think I'm going to start by taking this over to my parts washer and give it a good cleaning because it's pretty greasy, grimy right now. And once we get that done, we'll figure out how we get this gear off of here. There's got to be a set screw or a pin or something in there. I got to find it. I can't really see it right now because it's just so grimy. Let's go clean it up. I'm over here at the parts washer, and this is basically just mineral spirits running in here and good grease solvent. Great for cleaning up stuff like this. So we'll get in here and just get this cleaned out real good. Get all that grease and grime off of it. You see all the black coming off down there in the tray. That's all stuff coming off of this. So anyway, give me a little bit of time here. We'll get this cleaned up, and we'll see if we can figure out how to take it apart. Well, I am looking on this, I would assume that there would have to be some type of set screw or something in here to hold this gear in place, but I swear I do not see anything. The shaft up here, I can tell, is bulged on the end like someone's been hitting it with a hammer, which is going to make sliding it off really, really difficult. I'm going to probably have to take a file or something and file that out. Yeah. All right, let me see what I can do. There's a hole that goes through there. It looks like maybe, I don't know, maybe there was a pin or something in there, in a washer that would keep it from coming off that's not on there anymore. I don't know. But I'm going to start here because, like I said, I can tell. I don't know if you guys can tell, but it's bulged out, and there is all kinds of marks on there where it's been beat on and kind of swaged out a little bit. So we're going to press that off of there it's going to have to be reduced in size a little bit. We may end up having to make a new shaft for this before it's all said and done. Just not sure. Well, that's better. Still not convinced it's going to come off though. Let me figure out how I'm going to get that off of there. I'm going to have to put a puller or arbor press or something, but let me see what I can come up with. So I think the first thing I want to do is get all this stuff off the bottom. There's a little spacer right here that just seems to be kind of pressed up on there. And I'm kind of able to just use this as a slide hammer. And that looks like it's coming off. There it goes, across the shop floor, but I see it. That comes off. Got a little thrust bearing in there. That piece comes off. And of course, the part I really want to get off, it's keyed and pressed in place too. But I think that what I can do is press this shaft out on this side and get this whole piece out where I can then press the gear off the other end. So let me, I'm gonna go over to the arbor press and see if I can get this rigged up where I can just press this off, because I'm probably gonna have to make a new shaft anyway. And I'm over here at the arbor press, and I'm gonna see if I can press this whole shaft out. Hopefully this isn't gonna take too much pressure. There it goes. All right, that is off. That is off. So now I want to get the gear off. I've got my daisy plate turned around here. I'm going to support that gear up underneath the bottom best I can. And let me get a little extension to go right there to press that out with. All right, let's see what happens here. There it goes. All right, got the gear apart. All right, we got a jigsaw puzzle. Here's all the pieces and components to this, and of course the gear is the part that we're going to have to come up with a new one here, so kind of see what we got. Good news is I think with this we're going to be able to salvage this shaft. I may end up putting that on the lathe and just kind of polishing or turning or whatever just a little bit on that end to make sure we get the new one on, because it was a little tight coming off where it has been mushroomed. Like I said, it looks like someone beat on that and mushroomed it a little bit, but I think we can salvage it. So that's good. So I'm going to get all these parts bagged up, put together so we don't lose them, and let's see if we can figure out some information on this gear. So here is our broken gear, kind of cobbled back together, and I've gone and got my gear pitch gauge and determined that this is a 6-pitch gear. Diametral pitch is 6. It has, what did I say, 22 teeth. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21 teeth. 22. I had it right. I miscounted there. 22 teeth. And to do that, you need a number 5 cutter for a 6-pitch. I just happen to have an Involute number 5 6-pitch cutter. And it is a perfect match down there. So good news is I have the cutter we need to cut this with. So all I need is a gear blank to make it from. Now I could just buy a piece of solid cast iron. I could even do it out of steel or bronze if I wanted to, and machine it out. But I think what I'm going to do is we're just going to draw this up and have a casting made to make it like the original. We can make it pretty much exactly like the original, which I kind of like. So I think that's what we're going to do. All right, I'm going to go sit down at the computer and see if I can model this thing, and we'll go from there. So let me see what I can come up with. I'm also going to do the math and figure out what the actual diameter of this should be, and just kind of double check all that numbers while I'm at it. All right, I have got a little chicken scratch drawing here, kind of showing what I need to do. This is kind of a cross section of it. When we cast it, I'm not going to put the hole in the center. We'll machine that out later. We'll just cast it solid. But I think I got the information I need. I think I'll go in to the house and fire up Fusion 360 and see if I can't model this. We'll make it a split pattern, so there'll be a top half and a bottom half. When making patterns, there's a lot of things you have to take into consideration. You can't have any sharp corners. You need to have fillets in there. This actually, I measured that radius with some fillet gauges. Came in here and measured that radius. It's a 3/16 inch radius is what's in all these fillets in here. So you got little radiuses in the corners. I'll also have to make sure that there's no areas that have a straight side on them. I need to have drafts so that it'll pull from the sand. So like on these uprights here, they have to be kind of tapered in about one or 2 degrees. Not very much, but where it will pull out of the sand. And like I said, we'll make a split pattern, so it'll just have a parting line that goes right through the center here, and there'll be a top and a bottom that will go together, and we'll just put some pins in here where you can kind of index them together in the mold. And then we'll send that to the foundry, and I'll just 3D print it. The other thing I have to do is you have to factor in shrinkage. Cast iron shrinks, I think, about 1/8 inch per foot. So for every 12 inches, it's going to shrink 1/8 of an inch when it cools down in the mold. So you'll just have to go in and basically I'll draw it, and in the software I can just enlarge it by a certain percentage, and your pattern is just slightly larger than the original, so that when it cools and shrinks, it shrinks down to the correct size. So anyway, we'll go draw it up. I'm not going to show me modeling it because I'm not an expert in CAD. I'm good enough to get the job done, but a lot of you guys out there are a lot better at it than I am. But I'll show you the finished product. This shouldn't be a big deal to draw up. I think I know how to do everything I need to do on it, but I'll show you the finished product, and then, like I said, we'll send off that drawing and get a 3D print of it to send that to the foundry. And just as an example of what a pattern's going to look like, this is a pattern I made for a different gear. It's not for the gear that we're doing here, but a very similar process here. You can see it's got a split in there, so you got a top and a bottom. I got radiuses in there. You probably can't tell, but there's draft angles on all the sides. So basically, the foundry's going to, they'll put this in. They'll on a table like this. They'll put a flask or a form around it. They'll cram sand all in there, pack it real tight, flip it over, put another piece on the bottom. They'll put parting dust in between them, and they'll mold this half, and you'll have the 2 halves will be in the sand, and then they'll pull these out of the sand, and now you got a void in the sand that's the size of what you need. And then they'll basically just pour the molten cast iron into that, and voila, you have a casting. And usually Clark Easterling over at Windy Hill Foundry will do a video when he does stuff for me. I'll try to put a video up to that once we get to that point after he does it, so you can kind of see the process of doing the foundry work. But this is kind of what we will end up with, something very similar to this one. Different dimensions, but very similar. All right, let's see if we can show you here what we got. I went ahead and modeled the gear up in CAD. Like I said, I'm using Fusion 360. A couple of things here. You can kind of take a look at the pattern here. Let me kind of zoom it around, orbit it around a little bit. So, you can see we got our geometry in there. There's the bottom profile. A couple of things here. When you're making patterns, I think I mentioned this before. I'm going to mention it again because it's important. Number one, you got to remember this is going to be drawn from the sand. So you need to have draft angles on everything that's going to be coming out. So all of these inside surfaces here, the outside surfaces here, have a angle on them. And I just used a 1 degree angle. This is a pretty short length. You can use more of a taper. The more taper you have, the easier it pulls. But the bottom line is you want the part that's in the bottom of the sand to be smaller than the part that's in the top of the sand, so it will extract out. So there is a 1 degree angle on all of those surfaces. Next thing, no sharp corners in a pattern. If you have a sharp corner, you tend to get a cold shut in there, and a lot of times that'll be a place of a crack. So you always want to put fillets in any of your corners. So down here in the bottom, we got a little radius in there, and even on the top up here, we got a little radius going around there. That just really helps out a lot in the patterns. You always need to have those fillets in those areas, no sharp corners in there. Let's see, any of the machine surfaces, I added a little bit of extra material on there. My rule of thumb is I like to have about 1/8 of an inch of material to remove. So, the thickness was increased, the diameter was increased because we'll turn the outside diameter. Now this inside area, that's all going to be just rough casting, so we didn't add any extra material to that. But any of the surfaces that are going to be machined and finished, we want to add that little bit extra material in there. Again, we talked about shrink. Cast iron, I know just from experience, is going to shrink about 1/8 inch per foot. When you look at that on a percentage basis, that's about 1%. So you got about a 1% shrink. It's fairly easy in here. You can just increase the size of your drawing by 1%. And basically I just draw it up like I normally would. And then the last step I'll do is I will increase the size by 1% for cast iron. Different materials, brass, aluminum, bronze, cast iron, they all shrink at different rates. Talk to your foundry, ask what they recommend for shrink factor to make sure your dimensions will end up being right. On a small part like this, the shrink is so small it probably really wouldn't be that noticeable, but as you get to larger parts, it can become a bigger problem. I just, as a rule of thumb, I'll put it in on pretty much everything I've got. And then, like I mentioned before too, this is a split pattern, so there's 2 parts to it. If you look down the middle here, there's a top and bottom. I'm just going to turn half of it off. Okay, so that's one piece. This is the second piece. So when we print this, it'll be in 2 pieces. And I went ahead and just put a little hole in the very center because this is symmetrical. It doesn't matter if it's the position of the 2 faces to one another. So I just put a single hole in there. That's a 1/4 inch diameter hole, 1/4 inch deep. And what we'll do is we'll put a dowel pin in that, and that will allow us to put those 2 paths together and index them together. If it was the 2 sides timed to one another, I'd probably put 2 holes in it, 1 on each side, so that it would only go together in one direction. But anyway, we've got our 2 bodies here, the cope and the drag. And again, on this part, I'm just going to have it sent off to a friend of mine that has a 3D printer. He's going to print this for me. Typically, we just print it in PLA. Really, it doesn't really matter that much. You want to use a good printer. It's going to give you a fairly smooth surface. Some of them particularly some of the older printers, tend to be a little bit rough. The newer printers are doing so much better, but you need to have good smooth surfaces on it all the way around. What else is there? Oh, on the plastic, the PLA plastic, if it's a small production run like this, this is only going to be one casting, maybe a couple if he messes one up, it holds up fine. When you start needing 10, 15, 20 parts, something like that, the plastic will wear down in the sand fairly quickly. So, you know, for doing a production run, 3D printing is probably not the best route to go. If I was going to do this on a production run, I would probably send it out and have it done on a CNC router and have them route it out of some type of pattern board, which is kind of a plastic type material. You could also do it in 3D print and then let the foundry cast it in aluminum and then use the aluminum pattern. But if you do that route, you have to factor your shrink factor in twice. You have to shrink it for the aluminum, where the aluminum pattern will end up being big enough to take into account the shrink for the cast iron. So it's a little bit more complicated, but very doable if you want to make an aluminum pattern from your master pattern here. And that's something the big foundries often did. They would, in the old days, they'd make them out of wood. That would be your master pattern, and it would have a double shrink on it. They would use that to cast an aluminum pattern. That aluminum pattern would become your production pattern, and when that aluminum pattern wore out, they would go back to the master pattern and just cast a new production pattern. So anyway, pattern making on using CAD and 3D printers. This is so much easier. Back in the old days, I used to have to make these things out of wood. It's so much easier now. Well, until we can get our pattern made and get our casting back, that's about all I can do on this project for right now. So this is going to probably be several weeks before we can get in here and actually do the machining and finish this thing out, because we got to get it printed. That needs to be sent back to me. I have to send that to the foundry, get it cast, and get the castings back, which is going to take some time. There's a good chance if I can get these patterns back pretty quickly, I'm actually going to be going over to Mississippi to Windy Hill Foundry later this month for a little event that Clark's having. We may try to do the casting while I'm there, and actually let me have a video of the casting process. Usually when we go, we get a chance to take some patterns and mold up some stuff. So maybe this will kind of be a little project I can do while I'm there and get this poured and bring back. We'll see. I'm not going to promise that. Kind of depends on, again, whether we get the pattern back in time and whether Clark is actually set up to where we can pour. He's been working on getting a new furnace made, and he's hoping he's going to have that ready for us when we get there. But we'll see. If not, he'll get it to me and send it back later. But regardless, he'll make a video on it if I don't. So we'll have a video on the foundry process, which is always kind of interesting if you've never seen that process. Guys, with that, that's about all we can do today on this project. So that's going to be it. We're going to sign off here. Thanks for watching. Please subscribe if you haven't already. Hit that bell icon, get notifications when new videos are posted. A big, huge thank you to those guys who support the site financially through Patreon and PayPal. It gives me the time to be able to do all the work here that goes along, that's in addition to just working in the shop. And I tell you this all the time. There's a lot of work to running a YouTube channel. There's a lot of work that goes on behind the scenes, and it just makes everything go much longer. And that little bit of extra funding that comes from you guys that support the site, who like what we do, it really does make a difference. And we really thank you guys that do that. If you can't do it, no problem. But if you can, it does help. With that, guys, we're getting out of here. As always, thanks for watching.